Welcome to the timber bridge tutorial. The timber bridge has many parts to it, as you can see. The main bridge itself is divided into two main sections. The superstructure, which is from this section, also known as the girders, and above. And the substructure is everything below the girders. Let's tackle these two sections, one at a time. The substructure is made of different parts also. The timber bridge pictured here, also known as a trestle bridge, shows 3 trestle bents. So let's rip the superstructure off so we can see how the substructure is made. Starting with a trestle bent. Each trestle bent must be built the same way. We will cover why a little later. Each trestle bent has a cap, a sill, and posts. The cap, sill, and posts are made out of 12 by 12 timber. Depending on the length of your bridge, you may need more trestle bents. And if it's wider, you will need more posts for each trestle bent. On each side of the trestle bent is bracing. This bracing is called transverse bracing. There are 2 types of bracing on the substructure, transverse and diagonal bracing. It is easy to remember that the transverse bracing is on the trestle bent, as they both begin with the letter T. There are also scabs which are nailed into the cap and posts, and others into the sill and post. These are typically nailed into place with a 60D or 60-penny nail. Besides the nails that hold the trestle bent together, there are drift pins. The pin holes are 3/4 to 1 inch and are pre-drilled, and the pins are put into place with a square washer and hit with a sledgehammer. The pins may look like large screws on top, but don't let that fool you. Many personnel have wasted their time with a crescent wrench trying to unscrew them. Again, it's called a pin for a reason. The pins are put through the cap and through the sill at every post. The square washer on the pin could be 3 inch by 3 inch or 4 inch by 4 inch in size. The washer and the pin top must be below the surface of the wood on the sill or the cap. You will need to chisel out the area, approximately 1 inch or 1¼ inch, if not more, for it to fit perfectly under the height of the wood. We have covered the trestle bent, but what holds them together? In the case of our bridge, there are 3 trestle bents. They are held together by diagonal bracing. This is the secondary type of bracing on our bridge. The first was transverse, and we know that bracing is on the trestle bent because they both start with the letter T. Diagonal bracing is placed on both inside and outsides of the posts. One on the inside and one on the outside of the post when joining 2 trestle bents together. They must be placed in a crisscross manner and be placed at the topmost and bottommost part of the post, and should be touching the bottom of the cap or the top of the sill when nailed into the post. As I stated earlier, trestle bents need to be made the same. What I mean is that the transverse bracing must be going the same direction on each bent. The transverse bracing also does a crisscross if you look at it from the side. However, if you look at the bridge from the side, the left side of the bent all need the transverse bracing going in the same direction. When you do this, because of the crisscross method, all of the right side will be crisscrossing in the opposite direction. If this is done correctly, your diagonal bracing will be able to be placed correctly, and not incorrectly as it is on this bridge. Once we have the diagonal bracing on, it will need support for the 2x material. As you can see in the picture, there is a 12 by 12 square piece of timber in between the 2x material with a bolt, nut, and washers. A hole is drilled right in the center where the 2x material crisscrosses. Okay, now that we have covered the parts of the timber bridge substructure, let's recap on what we have learned so far. We have learned the trestle bent is made up of a cap, a sill, and posts. We have also learned that the transverse bracing is on the trestle, and it's easy to remember as they both begin with a letter T. And that all bracing must be the same for all trestle bents, or the diagonal bracing will not be placed properly. And scabs are placed on every open area where the post meets the cap or the sill, not including where the transverse bracing is placed. Pinholes are pre-drilled into the cap and sill, all the way through and into the post. And they will have to be chiseled out for the size of the square washer, for the exterior size and depth of the washer and the pin head thickness. Lastly, for the substructure, we talked about diagonal bracing, and how important it is to have the transverse bracing on the trestle bents going the same way. If they do not, then your bracing will not be placed correctly. The bracing needs to be in a crisscross manner and touch either the top or bottom most part of the post before being nailed into the post. We also talked about the 12 by 12 lumber for support. It is to be placed at the point where the bracing crosses in the center with a bolt, washer, and nut. Now that we have finished covering the substructure, let's dive right into the superstructure. Again, the superstructure starts at this point and up. This point is where the girders are located. The girders are the first part, or rather the base of the superstructure, and they lay directly on top of the trestle bent caps. They are placed approximately 3 foot 3 inches on center. The easiest way is to snap a chalk line on the tops of the caps at the center point. Then measure out for subsequent girders. This chalk line will represent the center of the girder, or if you need to put on more girders due to the length of your bridge, you will then place a girder on one side of the line, and the next girder on the other so they will overlap. Next comes the flooring. This will be placed perpendicular to the girders. At every 5 feet you will need to place a piece of flooring that extends out far enough, so that the kicker from the handrail post can be placed, and it can help support the curb risers. If you are not sure how much longer they need to be, 3 foot on each side will give enough room. The next thing we need to put in place is the treadway. This is what the vehicles will drive on while crossing the bridge. It adds support for the weight of the vehicle. These will be placed perpendicular to the flooring. The spacing of the treadway depends on the type of vehicles traveling over the bridge. The curb risers are next. They consist of 6 by 6 lumber and are typically 3 foot long. They are placed center atop of every piece of flooring that extends out 3 feet, however they do not go out further than the regular flooring. The curb is then placed on top of the risers and nailed down into the risers, just as the curb risers were nailed to the flooring. The next part to be placed is the extension. This is 6 by 6 material attached to the curb riser, and the flooring. Then a 4 by 4 post is then placed, as well as a 2 by 4 kicker, to help support the handrail. After you have finished with the kicker, you will then place a 2 by 6 handrail on top of the 4 by 4 posts, leaving enough room for a 2 by 4 to be nailed underneath the 2 by 6 towards the inside or walking area of the bridge. To recap on the superstructure, it consists of girders, flooring, treadway, curb risers, the curb, extensions, 4 by 4 posts, 2 by 4 kicker, 2 by 4 and 2 by 6 handrail pieces. There are many aspects of this bridge to cover. We just went over as a tutorial. Please let us know how we can help you in the future with tutorials or training.